When you hire a new coworker, someone who comes with just an absolutely glowing resume, there is this totally predictable initial honeymoon phase.
Oh, yeah, definitely.
Right. They seem to know everything. They speak with total authority on basically every subject. And so you just start handing off tasks to them left and right. You feel like, I don't know, an absolute genius for bringing them on board.
It is an incredible feeling.
Yeah.
I mean, you start to relax a bit. Maybe you stop double-checking their work quite as closely because, well, you trust it, that unshakable authority they project in every single meeting.
Exactly. But then it's always like one random Tuesday, they hand you a critical report and they state a fact with absolute unwavering confidence, and you happen to know for sure that the fact is completely demonstrably wrong.
Oh, the worst feeling.
It really is. And suddenly, all that trust just evaporates. You look at them and you think, well, if you could be so confidently wrong about this one specific detail, what else have you been quietly making up for the last 3 months?
Right? That is the exact moment the illusion shatters.
Mm.
And honestly, it is the perfect metaphor for the relationship most professionals are currently navigating with artificial intelligence right now.
Yeah.
I mean, we are all dealing with a very capable, very confident, but fundamentally flawed new coworker.
Which brings us to the mission of our deep dive today. Because this exact scenario is the focus of this brilliant internal playbook that's floating around the construction industry right now.
It's a fascinating document.
It really is. It's an AI boundaries guide. Specifically, it's looking at technical limitations. It's lesson A8, if you're keeping track. And its core philosophy just hit me right between the eyes. The tagline of this guide is, know what it can't do, then you'll trust what it can.
Which is just a profound operational statement. Because the professionals who are actually extracting massive value out of AI right now, the ones who are vastly outperforming their peers, they aren't scared of these technical boundaries.
No, not at all.
Right. They don't view the hallucination problem or the memory limits as a reason to just abandon the tool altogether. Instead, they understand the underlying mechanics of those boundaries really deeply. And that allows them to engineer their workflows intelligently alongside the machine.
And that is exactly what we are going to do for you today. Because whether you are literally standing on a construction site in a hard hat right now, or, maybe you are prepping for a boardroom meeting in finance or healthcare, mastering these mechanical limits is the ultimate shortcut.
Absolutely.
It is how you avoid getting duped by the machine. So we're going to explore 4 hard technical boundaries of AI today. And to do that, we really have to start with the concept of time. Because to actually trust an AI, you first have to understand that it is essentially trapped in a time capsule.
That's the perfect way to conceptualize it, really. I mean, we all know these models are trained on massive but finite data sets, and they have a hard cutoff date.
Right.
But the implication of that cutoff date is where people really get into trouble.
Okay, let's unpack this. Because the danger isn't just that the AI doesn't know what happened yesterday. It's like asking an incredibly well-read friend who have been locked in a cabin without internet for 2 years to give you a detailed analysis of this morning's financial news.
Right, yeah.
They have all the context in the world up to a specific date, but they're entirely blind to the present moment. And worse, they won't admit it.
What's fascinating here is the psychological trick the AI plays on us when it hits that temporal boundary. Because if you ask a human expert about a regulation that was passed, say, after they retired, they'll simply tell you, I don't know, I haven't read the latest update.
Exactly. A human has the self-awareness to just say they don't know.
But a base model AI operating without a live web search agent attached to it generally won't do that. And we had to look at the mechanism of why, because it's not trying to deceive you.
No, it doesn't have an ego to protect.
Right. It's a probabilistic prediction engine. It is mathematically compelled to complete the sequence that you started in your prompt.
Right. I mean, it's not a database querying a true or false table, and the guide gives a very specific, really high-stakes example of this. Let's say a new Australian standard for structural steel was published 3 months after the AI's training cutoff date.
Which happens all the time.
All the time. So, to the AI, that new standard simply does not exist in its neural weights. But if you ask it to summarize the current standard for your project, it will confidently present the superseded, outdated version as if it were the absolute law of the land today.
Because it sees your prompt asking for an Australian standard, and it activates the strongest semantic pattern it has for that specific standard, and it delivers it to you with perfect, authoritative, professional grammar.
Yeah, bullet points, bold text, the whole 9 yards.
Exactly. It is filling the temporal gap with older probabilistic weights that are now entirely legally obsolete.
And this gets even more dangerous when we talk about real-time fluctuating data. Because standard models, during inference, which is, when they are actively generating the answer for you, they have no real-time internet access unless you explicitly route them through a search tool.
Yes, that distinction is crucial.
Right. Which means asking it for current material prices or today's diesel rates or, checking if a subcontractor's registration status is currently valid. That is just a recipe for an incredibly expensive disaster.
It is highly dangerous. If you ask a standard unnetworked model for the price of copper today, it will give you a number, and it will give you a highly plausible sounding number.
Oh, that's not totally reasonable.
But it is fabricating that number based on historical price trajectories and textual associations, right?
Uh-huh.
It's not looking up the actual spot market rate on the web.
Oh.
The rule you really have to internalize here is that there is no real-time data without an explicit, verifiable search tool attached. You just must independently verify recent regulations and, frankly, never, ever trust a generative model for real-time rates.
Okay, but the hallucination problem gets even worse, though, when you realize it's not just blind to the present day. It's practically amnesiac about the conversation you're currently having with it. I mean, if the AI is trapped in the past, how does it handle the complex, real-time information you feed it during a live session?
Yeah, so this is a critical transition from historical memory to working memory. We are moving from the training data that we just talked about to the context window. And the reality of the context window is that it is a highly fragile, zero-sum environment.
The guide warns about this specifically for heavy admin days. So say you are uploading and reviewing multiple construction contracts, addendums, and email chains in a sequence over a 3-hour session. The guide actually states that the conversation will inevitably degrade and become completely unreliable.
It will just fall apart.
But wait, I have to challenge the practicality of the advice here. The guide suggests starting a new chat for every single document. But if I'm doing that, if I'm starting a new chat for every single contract, that seems incredibly inefficient if those contracts constantly reference each other.
Yeah.
How are you supposed to maintain consistency across a project if the AI has to literally be rebooted for every document?
See, it's a fantastic point. And honestly, it's the core tension of prompt engineering right now. You naturally want all the documents in one place so the AI has the full picture, right? But mechanically, the model's attention mechanism just can't handle it. You've got to think of the context window not as a bottomless hard drive, but as a physical tabletop.
Right. Eventually, the desk gets full.
Exactly. But it's not just that documents fall off the edge when the desk is full. It's that the AI's attention becomes diluted.
Oh, interesting.
Yeah. When you dump 80 pages of text into a prompt, the model has to distribute its attention weights across all those tokens. We see this highly documented phenomenon called lost in the middle.
Lost in the middle.
Yeah. The AI will remember the first contract you uploaded perfectly, and it will remember the very last instruction you gave it. But the critical liability clauses in contract number 3, which is buried right in the middle, its attention mechanism functionally just skips over them.
So it's not that the AI has a bad memory per se, it's that its attention span is literally a zero-sum game. Every new document I add mathematically reduces the attention it can actually pay to the very first document I uploaded.
Precisely. The attention signals become incredibly noisy. So it might cross-contaminate a penalty clause from contract A with a timeline from contract C.
Which is terrifying.
Right. So to answer your challenge about efficiency, the solution isn't to just dump everything into one giant chat. The solution is modularity.
Okay, modularity. Walk me through what that looks like.
Sure. You open a chat, you analyze contract A, and you have the AI generate a hyper-condensed summary of the key liabilities, just the core facts. You take that one-page summary, open a completely new chat, and feed it that summary alongside contract B. You are manually managing its attention span.
Okay, wow. That is a massive paradigm shift for how you use the tool. You are basically acting as the project manager for the AI's working memory.
Exactly. You have to guide it.
Okay, so we've established that the AI's working memory degrades when it gets overloaded with text. But here's where it gets really interesting. What happens when you ask it to process raw, complex math inside that fragile working memory? Because the guide draws a massive, bright red line between words and numbers.
Yes. And this is perhaps the single most dangerous area for professionals
Yeah.
because, the interface looks like a computer terminal, right?
Mhm.
So we automatically assume there must be a deterministic calculator running under the hood.
We just assume computers are flawlessly good at math. That's what computers do.
Exactly.
Yeah.
But large language models are precisely that. They are language models. They are not calculators.
And the guide gives a perfect, honestly, kind of terrifying example of this. Let's say you need to submit a variation claim on a project. So a request for an additional $200,000 because the scope of work changed due to unforeseen ground conditions.
Very common scenario.
Right. So asking the AI to draft the narrative for that claim, to synthesize the site diaries and explain why the delay happened in highly persuasive professional language, that is an excellent use case.
Yeah.
Because that is linguistic synthesis.
Spot on. But the flip side is where people absolutely ruin their credibility.
Tell me about it.
If you give that same model a massive table of total labor hours across 47 different cost codes, and they all have different union rates, overtime multipliers, material costs, and then you ask it to calculate the final quantum for the variation claim, you are quite literally playing Russian roulette with your project budget.
But why does it fail so spectacularly at this? I mean, if it can write a perfect sonnet about a bulldozer, why on earth can't it just add 47 rows of numbers?
So if we connect this to the bigger picture of how the architecture actually processes data, it all comes down to tokenization. You and I, when we look at the number 14,250, we see it as a single, holistic mathematical value.
Right. 14,250.
But the AI's tokenizer doesn't see it that way. It breaks that number down into structural fragments. It might see the digits 14, then it sees a comma, then maybe 25, and then a 0. It doesn't inherently understand the base 10 mathematical relationship between those fragments.
I mean, really? So it's treating the numbers exactly like syllables in a word.
Exactly. It's just shapes and patterns to the AI. When you ask it a complex multi-step math problem, it doesn't suddenly pivot to executing a mathematical algorithm. It just continues predicting the next most probable token.
That is mind-blowing.
Right. It looks at your prompt, it sees a list of 47 cost codes, and it tries to predict what the overall shape of the total sum should look like based on similar textual patterns it saw in its training data.
So it's essentially looking at this long string of numbers and saying, well, based on my linguistic weights, the total for a list of this length usually looks something like $142,000. And it produces a number that looks aesthetically flawless. Like it has the dollar sign, the commas are in the exactly right place. It might even confidently generate a bulleted list of fake working out steps to prove its logic to you. But it is fundamentally mathematically fabricated.
It is plausible math, which is honestly the most dangerous kind of math.
Yeah, because you believe it.
Right. It will confidently fail at percentage calculations, compounding interest, or multi-step equations. The takeaway for your workflow is absolute here. Generative models draft, spreadsheets calculate. You must never conflate the two domains.
Okay, that is a golden rule right there.
For any actual financial calculation, I'm talking project cost, variation quantum, earned value metrics, or boardroom revenue projections, you always use a deterministic calculator or a spreadsheet. You simply cannot trust an attention-based language model's arithmetic.
Got it. So we are keeping our math safely quarantined in a spreadsheet from now on. But if we are using the AI to draft the text of those variation claims or, to summarize 80-page legal contracts or to process internal project correspondence, we really have to pause and look at the final boundary here. Where is all that sensitive text actually going?
This raises an important question about the corporate boundary, which focuses entirely on confidentiality and data architecture.
Because when I paste a highly sensitive legal document into a commercial AI platform's text box, I'm not just processing it locally on my laptop's hard drive, right?
No, absolutely not. You are transmitting that data over the open internet to a massive server farm somewhere for processing. And the implications of that transmission depend entirely on the tier of service you are actually using.
Okay, break that down for us.
The guide points out that if your company pays for a specialized enterprise tier of an AI service, those agreements usually include strict data privacy partitioning. So they legally guarantee that your inputs are siloed, and they will not be used to train their future public models.
Right. But let's look at the mechanism of what training on your data actually means for the people out there using standard, public, or free tiers. Because it's not that the AI is saving your contract as a PDF to just hand over to a competitor. It's way more insidious than that.
Far more. If you use a public model, your proprietary data, let's say a highly innovative, incredibly aggressive penalty clause, Your lawyers just spent weeks drafting.
Yeah.
That text is broken down and its semantic relationships are absorbed into the model's neural weights.
Right.
It literally alters the probabilistic math of the model. Which means 6 months from now, when your competitor asks the AI to help draft an aggressive penalty clause, the model might effortlessly regurgitate the exact structure and phrasing of your proprietary legal strategy.
Yeah.
Because your data taught it how to do that.
That is a massive intellectual property leak happening in plain sight.
Yes, it is.
And the guide notes that even with an enterprise agreement, where the data isn't theoretically used for training, you still have to be incredibly careful. I mean, routine project documents, daily reports, general specifications, those are fine. But what about legally privileged communications from your legal counsel? Or documents covered by a strict non-disclosure agreement?
That is where the legal risk skyrockets. Legal privilege is often predicated on the absolute restriction of third-party access.
Right.
Even if the AI company has a highly secure enterprise server, simply transmitting that privileged communication to a third-party processing environment without explicit prior legal safeguarding that can inadvertently void the privilege entirely. Opposing counsel could easily argue the communication is no longer protected.
So you could win the battle of getting a great quick summary, but completely lose the war by voiding your own legal protections. The golden rule here seems totally non-negotiable. You must know your organization's specific AI usage policy and really understand the platform's data handling architecture before you paste anything. And the ultimate fail-safe the guide recommends. When in doubt, redact.
Yes, redact everything.
Just strip out the identifying information, the client names, the specific dollar amounts before you ever hit enter.
Using these tools efficiently isn't just about prompt engineering anymore. It's about holistic risk management. The technology is extraordinarily powerful, yes, but it requires an educated, highly disciplined operator to mitigate the unseen risks.
When you lay it all out like this, it completely reframes how you look at the tool. I mean, when you realize the AI doesn't know today's dates and it forgets what you said an hour ago and it can't do basic math and it might inadvertently leak your NDAs, it really forces you to stop acting like a passive consumer of its answers and start acting like an active, highly skeptical editor.
That's the mindset shift right there.
Which really brings us to the most fascinating question of all.
Exactly.
Yeah.
Because at the very end of the source material we reviewed today, the authors tease the next lesson in their curriculum. It's titled Behavioral Risks of AI on Site. And it moves entirely from the technical hardware to the human wetware.
Yeah, we've spent this entire deep dive mapping out the hard technical boundaries. We've got time capsules, context windows, tokenized math, and data partitioning. But those limits are really just the baseline rules of engagement.
They are. The real existential question you need to mull over as you integrate these tools into your daily workflow is this. If you lean heavily, day after day, on a machine that constantly gives you highly confident, perfectly formatted, flawlessly grammatical, yet occasionally fabricated answers, how does that subtly change your professional behavior?
Right. Does relying on AI fundamentally alter the way you make complex decisions? Does the sheer convenience of getting an output in 5 seconds erode your instinct to double-check the raw data?
Does it dilute your sense of personal accountability? I mean, when you hit print on a report that the AI basically drafted and you hand it to your boss or your client, are you still taking the exact same level of intellectual ownership over every single word?
It brings us right back to that overconfident new coworker we talked about at the very beginning. If you let them do all the heavy lifting, if you stop checking their math and you stop verifying their historical facts, eventually their inevitable mistakes become your mistakes.
And you can't just blame the coworker when things go wrong.
Exactly. You can't just blame the coworker when the structural integrity of your project, or frankly your career, collapses. You have to know their limits intimately so you can actually harness their strength safely. So think about your own workflows the next time you open a chat window. We'll see you on the next deep dive.